Welcome back to part 8 of our DIY Autonomous Mobile Robot building series. If you missed any of parts 1 through 7, you can find the links in the video description below or access the full playlist at the end of this video. In part 7, we finished all the reference elevational drawings and then used the form tool to 3D model the body shell. Now in part 8, we will start to insert some components and arrange these components so they don't interfere with each other or the body shell. Anyway, carrying on, regarding the 1mm thick tail, I had to combine that with the body separately because you can't create a 0.5mm shell from a 1mm thick object. But first of all, I made a copy of the body using the Move Copy tool, switch on Create Copy, and then press OK, upon which a new body, body 3, appears in the browser. Then, when we select the Combine tool, we select the 1mm thick tail as the target and body 3 as the tool and select Cut for the operation and press OK. And now we can see the cut line through the tail with bodies Tail 1 and Tail 2 showing in the browser. Right click on Tail 2 and select Remove. Next, unhide the original body and combine the remaining tail, Tail 1, with the body. And there we have the initial body shell completed. Now we're back at the chassis construction file and inserted the body shell. A section analysis shows the current state of the head and body and the neck and tail also. Here I have hidden the body and zoomed in from the top side or the plan view. Now I will insert this caster wheel 3D model which I have created separately and is available to download for free on GrabCAD. Check out the link in the description to access this design. So the caster wheel has landed on the origin, so we'll move it along the center line and turn it around. Switching to the side elevational view, we can see that the caster wheel is positioned too high and that the center of the caster wheel needs to align with the center point below it. To do that, we will select Align from Modify, hide some of the bodies within the caster wheel in the browser, and let's select the outer cylindrical surface of the spindle for From and unhide all the bodies. Select the center point for 2 and hit OK. And there we have the caster wheel in the correct location. Okay, so I had the bodies of the wheels hidden, so I'll unhide those. Unhide the body shell, and there we can see the positional relationship between the left and right wheels, the caster wheel, and the body shell. Here I've started to insert more components. I have an AA battery holder at a random position. This battery holder holds 4 AA batteries and has a switch just like the actual battery holder that I'm using for this build. I have also inserted a Hi-Tech HS311 servo. I am just rotating and moving it around to an approximate position. I created both 3D models of the battery holder and the servo using Fusion 360, and I have uploaded step files to my GrabCAD account. Check the description for the links to both of these models. As you may know, I already have a 3 video series showing how I created a 3D model of the Hi-Tech HS311 servo using Fusion 360. Check the link at the end of this video to see how I created that. So due to the limitations on the size of the robot, in order for the sizes of the wheels and the ultrasonic sensor to be in proportion, it is quite a challenge to determine the positions of the various components such as the servos, the battery holder, and also the Arduino circuit board and the 9-volt battery. So our robot is going to have a very compact design. If I place the battery holder at an approximately vertical position at the front here, the corners will interfere with the front body shell. So I tried a vertical position for the servo to allow the battery holder to move back more, but 2 of the corners still easily interfere with the body shell here. Also, we'll need to allow for the removal of the battery holder for changing the battery. So I don't think I'll be keeping the battery holder at this position. There's actually a more pressing issue, and that is the switch needs to be externally accessible in order to actually switch on the robot. So I will need to move the battery holder from this present location. Before I go on to that though, I think think I will attach the servo to one of the wheels. But first, before we do that, we want to make sure that the wheel doesn't move out of position and move to the position of the servo horn instead of the other way round. So we right click on each wheel and select ground. Now we can join the servo horn to the wheel. So we'll hide the wheel, select joint, select the center of the servo horn, and then unhide the wheel and select the center of the inner side of the wheel. The easiest way to select the correct snap position is to hover the mouse over the surface or plane to which you want the other component, the servo horn in this case, to abut against. Hold down the control key on your keyboard, and then all the snap points on that plane become selectable, and then left click the snap point at the center and then hit OK. Upon which the servo horn together with the servo body slides into position. Now it looks as though we have very little clearance between the inner circumference of the wheel and the top two corners of the servo body, although it might be enough, but we might have a bigger problem actually. It looks as though there would be no room for the servo grommets, so we can confirm that now. Here I have inserted a servo grommet. Each left and right servo needs 4 grommets along with 4 eyelets for fastening the servos to the chassis. I have uploaded a step file to my GrabCAD account which can be downloaded and imported into Fusion 360. The link for this grommet is in the description. Zoom into the grommet, select joint from assembly, glide the cursor over one of the inner faces of the grommet, hold onto the control key so that all the snap points on that plane will show, and you can simply select the center on that plane. Then zoom to the mount surface to the servo, glide the cursor over the surface of the mount, hold onto the control key and then select the center of one of the openings. And there the grommet glides into place. However, there's a bulge on the central portion of the grommet that needs to align with the outer opening of the mount hole. So we can just rotate the grommet until you can see the bulge. I think now is a good time to make a copy and to move the copy to the adjacent opening. I also made a rigid joint again in the same manner as the first grommet. I'm going to have a lot of joints in this design, so it's always best to label your joints. I've labeled this one grommet to servo. Now it's time to unhide the wheel, and we can see that the grommets do in fact interfere with the wheel as I had suspected. So we'll go back to the joint between the servo horn and the wheel. I'll just label it while I'm at it to servo to wheel, and then edit that joint by moving the servo horn away from the wheel by 3.7 millimeters, which is the thickness of the HDPE board that I'll use as a spacer between the servo horn and the wheel. And just zoom in there and we can see that there is enough clearance between the wheel and the servo body and its grommets. Okay, hide the wheel again. Select new component from create, label it wheel spacer. Now the wheel spacer component is activated. Select the main surface on the servo horn and then create sketch. Now there's actually an inner boss on the servo horn here, so we'll initially design a spacer that goes around that. Finish sketch and extrude by first selecting the surface on the servo horn. You might need to hold down the shift key and select all the small holes too, like I needed to. Then extrude by 0.5 millimeters so that the face of this initial spacer is even or flush with the face of the inner boss. With the wheel spacer still activated, create a new sketch on the surface of the new 0.5 millimeter thick spacer. All we need to do is to press the P key for project, select the outermost circumference of the spacer we have just created and hit OK, thereby projecting that circle to the current sketch. Then extrude again, this time by 3.7 millimeters, while selecting that surface and the inner surface area as well. So we end up with a 0.5 millimeter thick washer type of spacer and also a separate 3.7 millimeter spacer on top of that. I'll just do a 0.2 millimeter fillet on the outer cylindrical surface of the spacer there. To continue, click here for part 9. If the link is not showing, then part 9 is not quite ready, but should be ready soon. Check out the description for my uploading schedule. Thank you for watching.